Your 2021 Ford F-150 with the 5.0 LV8 has factory program behaviors built straight into the powertrain control module that are quietly cooking your engine from the inside out, and the dealership service department is laughing all the way to the bank while you pay for premature component failures. Most owners believe that whatever rolls off the assembly line is optimized for longevity and peak performance. That is the exact lie that keeps my shop fully booked. Today, I'm exposing 5 factory settings and calibration features on your truck that are causing hidden damage, waste, and mechanical inefficiency without you knowing. Setting number 5 is quietly degrading your oil control rings. Setting number 4 is inducing localized thermal stress on your cylinder walls. And setting number 1 is a completely deceptive software trick that makes you think your engine is running safe when it is actually leaning out under heavy load. Let's get into it. Setting number 5 is the factory aggressive deceleration fuel cutoff calibration. When you lift your foot off the accelerator pedal at highway speeds, the powertrain control module instantly cuts fuel injectors to 0 to maximize your EPA fuel economy ratings on paper. Owners think this coast-down fuel starvation is a harmless, high-tech way to save a drop of gas. But here is what Ford doesn't tell you. When those injectors slam shut while your engine speed is still elevated at 2,500 revolutions per minute or higher, cylinder temperatures drop precipitously within milliseconds because no combustion is taking place, yet air is still being pumped through the bores by the momentum of the truck. This sudden thermal shock causes the aluminum piston skirts to contract faster than the cast iron cylinder liners, momentarily widening piston-to-wall clearances beyond the tight tolerances engineered for sealing. Over tens of thousands of miles of daily commuting, this repeated micro-contraction cycle allows microscopic amounts of raw oil to travel past the oil control rings and pool on the piston crowns, accelerating carbon crusting on your compression rings until they stick in their grooves. I have pulled pistons out of these 5.0L engines at 80,000 miles with oil rings completely carbon solid into their lands, all because the computer was programmed to cut fuel aggressively every time you rolled up to a red light. The consequence is an engine that starts consuming a quart of oil every 1,500 miles, long before it should ever see a wrench. The solution doesn't require a tuner or a software flash. Change your driving behavior in stop-and-go traffic by anticipating stops smoothly rather than executing abrupt pedal lifts, and shorten your oil change intervals to 5,000 miles using a high-detergent full synthetic oil that prevents those ringlands from baking solid. Setting number 4 is the factory electronic thermostat target operating temperature, mapped to 210 degrees Fahrenheit and higher under light load cruising conditions. Ford programs the map-controlled thermostat to run the engine hot during highway cruising to lower internal friction and eke out another decimal point of fuel economy for federal compliance. Most truck owners look at the dashboard temperature gauge, see it sitting dead center, and assume that optimal heat means optimal protection. But under my borescope and inside the teardowns I've performed, that elevated operating temperature, combined with modern low-tension piston rings, cooks the engine oil at the ring interface, turning standard synthetic oil into a varnish-like lacquer over time. When your coolant temperature is held at 210 degrees under light loads, the actual localized metal temperature at the top ring zone exceeds 260 degrees, which is the exact threshold where modern Group 3 synthetic base oils begin to thermally shear and leave behind lacquer deposits. This lacquer acts as an insulating blanket, trapping heat inside the piston crown, which then leads to localized pre-ignition hotspots, increased oil consumption, and accelerated wear on the cylinder wall crosshatch. Ford markets this high operating temperature as a high-efficiency thermal management system, but under the valve cover, it is creating the exact environment that promotes sludge accumulation in the dead corners of the cylinder head. The fix is remarkably simple. Stop relying on the idiot light on your dash and monitor your actual coolant and oil temperatures via an OBD2 scanner. If you tow or haul regularly, or even if you just drive in heavy summer heat, switch to a high-performance 5W30 synthetic oil that maintains its shear strength well above the factory temperature thresholds, and never let your oil sit in the pan past 5,000 miles, regardless of what the intelligent oil life monitor on your dash tells you. Setting number 5 and setting number 4 already showed you how factory software cuts corners with your oil life and cylinder temperatures. But the calibration gremlins hiding further down the list are where the real mechanical damage starts compounding. Setting number 3 is the factory adaptive cam phasing strategy, mapped to aggressive valve overlap during low-speed, light-throttle cruising. Ford's variable camshaft timing system on the 5.0L Coyote V8 is designed to endlessly chase emissions targets by opening intake and exhaust valves simultaneously during the exhaust stroke, intentionally pushing a controlled slug of inert exhaust gas back into the intake runners to dilute the incoming fresh charge and lower oxides of nitrogen. Truck owners assume this variable valve timing magic is purely a clean air benefit that operates with zero mechanical downside. But here is what Ford refuses to put in the brochure. When you are crawling through rush hour traffic or idling in your driveway with a hot engine, that aggressive valve overlap dumps massive quantities of hot, particulate-laden exhaust soot directly back across the intake ports and onto the back of the intake valves. Even though the 5.0L features port fuel injection to help wash the valves, at low engine speeds, the fuel injector duty cycle drops so low that the meager amount of detergent spray cannot keep up with the relentless volume of hot soot being barfed backward through the valve opening. Over 50,000 miles of city driving, this exhaust gas recirculation creates a hard, baked-on carbon crust that chokes down the intake port cross-sectional area by up to 15%. I have measured the flow benches on these cylinder heads, and that restricted airflow turns into uneven cylinder filling, a subtle, rough idle that dealerships dismiss as normal operating characteristics, and a progressive loss of throttle response that creeps up on you so slowly you never notice it until you drive a brand new truck off the lot. The solution requires changing how you drive your truck on the weekends. Stop treating your F-150 like a grocery getter that only sees short 5-minute hops to the store. Take that truck out onto the highway once a week and hold it at sustained RPMs for 20 minutes to get the combustion chamber temperatures high enough to thermally shock and naturally burn off those accumulated soot deposits before they cement themselves permanently to your valve stems. Setting number 2 is the factory closed-loop adaptive fuel trim learning parameters programmed with an absurdly wide correction window of plus or minus 20%. When your mass airflow sensor gets a microscopic coating of dust, or your throttle body accumulates a thin film of crankcase vapor, the powertrain control module quietly compensates by shifting the long-term fuel trims to keep the air-fuel ratio stoichiometric without ever triggering a check engine light. Owners look at their instrument cluster, see no warning lights, and assume their fuel delivery system is operating at peak factory perfection. But here is the brutal mechanical reality. By allowing the computer to silently mask minor air leaks, dirty MAF sensors, and sticky purge valves up to a 20% correction factor, the engine is secretly running in a compromised state where individual cylinders are fighting wildly different air-fuel ratios. When cylinder 1 is running 4% lean, while cylinder 8 is running 6% rich due to uneven manifold distribution and wide trim compensation, you induce micro-detonation events in the lean cylinders that hammer the rod bearings with thousands of tiny pressure spikes every minute. I have torn down bottom ends on engines that never threw a single trouble code, only to find the upper rod bearing shells showing distinct pounding marks and copper showing through the Babbitt overlay, all because the computer was working overtime to hide a failing sensor input instead of alerting the driver to a developing mechanical imbalance. The fix is absolute and non-negotiable. Stop waiting for a dashboard light to tell you your engine needs attention. Clean your mass airflow sensor every single time you change your engine air filter using dedicated MAF cleaner. Inspect your intake tract for unmetered air leaks at every oil change, and force a KAM reset through an advanced scan tool whenever you clean your throttle body so your fuel trims start back at a clean baseline instead of masking chronic mechanical inefficiencies. Settings 5 through 2 have already shown you how factory thermal management, idle recirculation, and lazy fuel trim compensation are silently wearing down your engine's internal components long before their time. But the single most destructive, aggressively marketed, and outright deceptive factory setting on your entire truck is hiding right at the top of the list, disguised as a high-performance safety feature. Setting number 1 is the factory knock sensor retard recovery algorithm, mapped with an ultra-aggressive timing pull threshold tied directly to low-tier fuel detection. When you roll up to a discount gas station and fill your tank with cheap 87-octane non-top-tier fuel, the moment your engine encounters a heavy load or a slight thermal spike, the piezoelectric knock sensors strapped to the block detect micro vibrations of detonation. Ford programs the powertrain control module to instantly pull up to 8 degrees of ignition timing across all 8 cylinders to protect the pistons from melting. Dealership marketing materials tell you this adaptive spark control is an advanced safety net that ensures your engine runs safely on any grade of fuel you throw at it without skipping a beat. But here is the brutal, wallet-emptying mechanical truth. That aggressive timing retard doesn't just eliminate knock, it drastically reduces your thermal efficiency, turns your combustion chamber into a literal blowtorch, and dumps partially burned fuel directly past the rings into your crankcase. When ignition timing is constantly yanked back by 8 degrees, the peak cylinder pressure occurs too late in the power stroke, forcing the burning gases to sweep across the exhaust valve seats while they are wide open. This superheats your exhaust valves, cooks your catalytic converters with excessive unburned hydrocarbon spikes, and raises your oil dilution levels through the roof because that retarded spark prevents complete combustion. I have pulled oil samples out of trucks running cheap gas with fuel dilution numbers high enough to drop the kinematic viscosity of a 5W30 oil down to a thin 5W20, literally starving your main bearings of the hydrodynamic film strength they need to survive under load. The manufacturer programs this safety net so they never have to warranty a melted piston when owners run garbage fuel. But the hidden price you pay is chronic thermal abuse, degraded oil shear strength, and permanently sluggish throttle response. The fix is a total shift in your fueling mindset. Stop treating octane as a flexible suggestion, and stop buying discount, non-top-tier regular gas just to save $3 at the pump. Check your owner's manual, verify your fuel requirements, and stick exclusively to top-tier certified fuel retailers so your engine's computer can run its factory timing tables without constantly pulling ignition advance and cooking your oil. We have just torn through 5 factory calibrations that manufacturers designed to pass emissions tests on paper while slowly eroding the mechanical integrity of your truck behind your back. If you take nothing else away from this teardown, remember that your vehicle's computer is not your friend. It is an emissions lawyer programmed to protect the bottom line of the corporation, not the long-term health of your bank account. Stop trusting the factory maintenance intervals, stop ignoring the minor sensor drifts and oil dilution warning signs, and start taking active control of your truck's maintenance before a minor calibration quirk turns into a major engine rebuild bill. If this deep dive opened your eyes to what is really hiding under your hood, hit that subscribe button right now, because our next long-term teardown is about to expose the exact synthetic oil change intervals that oil companies spend millions trying to keep quiet. Drop a comment below telling me your truck's mileage and how often you've been changing your oil, and I'll tell you if your bearings are already on borrowed time. Stay sharp, wrench smart, and I'll see you in the next breakdown.